So let's see where we're at so far. We've made a sketch. In step 1, we made a sketch of our situation so we could get an overview. And in step 2, we sketched the regions. What that allowed us to do was come up with the limits on the double integral. So now step 3 is going to be to get a formula for z. Well, the only fact that we know about z is just the equation given in the question, x plus y plus z equals 2. But we can solve that equation for z and get the formula z equals 2 minus x minus y. So that's what we're after here. In some problems, the formula for z is given to you. In other problems, sometimes you just have to do a step or two of algebra like this to solve for z. Great, so now we're all ready to jump down to step 4, which is to set up our volume. So you may remember from our discussion, right at the beginning of the volume discussion, we said that volume is computed by double integral. What we're integrating is z. We're going to integrate with respect to y first, and then with respect to x. And we have to integrate over the appropriate region A. All right, so in thinking about our double integration, then that's where these limits of integration really come into play. Let's remember that the inside integral is going to match up with the inside differential, and the outside integral will match up with the outside differential. So let's just be aware of that as we put our limits on the integrals here. So we said that y is going to range from 0 to 2 minus x. And notice those limits are going on the integral associated with y. And then the outside integral is associated with the dx, or the x variable. So the limits on that integral are going to be 0 to 2. There we go. So we've correctly labeled our double integrals. The other thing that needs to happen is we need to replace z with the specific formula for z, which we figured out in step 3. So what's going inside the integral here? 2 minus x minus y. We made our big sketch in step 1. In step 2, we figured out the limits on the double integral. In step 3, we figured out a specific formula for z, and now in step 4, we're building it all together into the volume formula. So from here on out, it's just going to be going through the algebra, the calculus and the algebra of computing this double integral, and then we'll have our volume. So in doing this computation, we're going to start with the inside integral. The dy here tells us that we're going to be integrating with respect to y, and that means that we're going to be treating x just as a constant. We're going to treat x as any other number as we go through this part of the calculation. Okay, so let's continue our work over here. I'm going to recopy the first integral, but we won't be working with it at this point. And I'm going to recopy the dx at the back here, and all of our work is going to be taking place inside this integral here. Okay, so I think for the sake of keeping the algebra streamlined, probably the best thing to do here is just to think of this 2 minus x as being a constant. If x is a constant, 2 minus x is a constant. And when we integrate that with respect to y, we get 2 minus x times y. Okay, so that's those terms dealt with. And then continuing to integrate, we get minus y squared over 2. So we've now integrated with respect to y. And then in our next step, we need to evaluate. Since we integrated with respect to y, it's going to be y values that are getting replaced here. So first we'll replace y with 2 minus x, and then we'll replace y with 0. And those limits are just coming from the limits on the inside integral there. So let's recopy the integral, we'll recopy the dx, and we'll go through our evaluation step here. So let's sub in y equal 2 minus x. That's going to give us 2 minus x times another 2 minus x. So maybe we should just call that 2 minus x all squared, minus 2 minus x all squared over 2. And then we need to subtract off what we get when y is equal to 0. Well, fortunately, when y is 0, both of those terms are going to be 0. So I'm just going to say minus 0. Okay, I'm going to switch to a different color now just for fun, and let's see if we can clean up this integrand. So we're going to keep our integral and our dx on there, and let's look what's going on inside the integral. So we've got this square here, and then we're seeing another like term with that. We're seeing that same square coming up again, and let's ask ourselves how many of those squares do we have? Well, we've got one of them, so meaning 2 over 2 of them, and then minus 1/2 of them. So overall, we've got 1/2 of that square. So you can see I'm just avoiding expanding out these squares. If you felt more comfortable, of course you could just expand it all out. That's fine too. But I'm just trying to streamline the algebra a little bit here. So it's really personal preference as to whether you want to use these little algebra tricks or whether you just feel more comfortable expanding it all out. Okay, so I would say 1/2 of 2 minus x all squared is probably the very easiest way to write that. Okay, now we've got one more integration to go. You could consider doing substitution here, but I'm going to suggest why don't we just expand out the integrand and simplify it that way. So I'm going to keep the half out in front, and let's expand the square. We're going to have 4 minus 4x plus x squared. And if we distribute the half there, we'd have 2 minus 2x plus x squared over 2. Okay, so this work here, that's just simplifying the integrand. We still have to do the actual integration. So continuing over here, I'm going to copy down the integral, copy down the dx, and we're just going to clean up that integrand now. We've simplified that. We know a simpler way to write it is 2 minus 2x plus x squared over 2. Great, so we're all set to do our final integration now. Integrating with respect to x, we're going to have 2x minus x squared plus x cubed over 6. And we're going to evaluate that at 2 and then at 0. So plugging in, we get 4 minus 4 plus 8 over 6. And then, as we sub in x equals 0, we're getting 0 all the way across there. So final answer would be 8 over 6, or you could reduce that, call that 4/3. I hope you found this example helpful in terms of going over all the geometry and then going over all the practice of the double integration itself. So thanks for watching, and we'll see you in the next video.